Energy of a system and conservation of energy. In the system model, we focus our attention on a small portion of the universe, that is the system, and ignore details of the rest of the universe outside of the system. A critical skill in applying the system model to problems is identifying the system. A valid system may be a single object or particle, may be a collection of object or particle, may be a region of space, may vary with time in size and shape. We also identify the system boundary. System boundary are imaginary surface which divide the universe into the system and the environment surrounding the system. A system may be isolated or non-isolated. An isolated system is one for which no energy crosses the boundary of the system. Non-isolated system is one for which energy crosses the boundary of the system during some time interval due to the interaction with the environment. Ways to transfer energy in or out of a system work by applying force to the system such that the path of application of the force undergoes displacement. Mechanical wave by allowing disturbance to propagate through air or another medium. It's the method by which energy leaves the system of your radio through the loudspeaker and enter your ear to stimulate hearing process. Heat. Mechanism of energy transfer that is driven by a temperature difference between a system and its environment. Heat is a method of transferring energy, not a form of storing energy. Matter transfer. Matter physically crosses the boundary of a system, carrying energy with it. Electrical transmission involves energy transfer into or out of a system by means of electric current. Electromagnetic radiation refers to electromagnetic wave such as visible light, microwave, crossing boundary of a system. For example, from sun to earth by light. A central feature of the energy approach is the notion that we can neither create nor destroy energy, and energy is always conserved. This feature has been tested in countless experiments. Therefore, if the total amount of energy in a system changes, it can only be because energy has crossed the boundary of a system by a transfer mechanism. The most general statement describing the behavior of a non-isolated system is the conservation equation. Change in energy of system is equal to summation transfer. Change in kinetic energy plus change in potential energy plus change in internal energy is equal to work plus heat plus matter transfer plus mechanical wave plus electrical transmission plus electromagnetic radiation. Conservation of linear momentum. The principle of the conservation of linear momentum states that if two or more bodies collide in a closed system, the total momentum after the collision is equal to the total momentum before the collision. This principle follows Newton's second and third laws of motion. Consider two bodies A and B of mass ma and nb moving towards each other with velocities ua and ub. When the two bodies collide, one of the two occurs, elastic or inelastic collision. If in the collision the total kinetic energy is the same before and after the collision is said to be completely or perfectly elastic. Thus, in such an elastic collision, both the momentum and the kinetic energy are conserved. In an inelastic collision, the kinetic energy decreases after the collision, but the momentum is still conserved. In inelastic collision, the colliding bodies stick together and move with same velocity.